All right. So, hello and welcome everyone. We are live right now. All right. So, welcome back to this amazing platform of Tutee Learning. And today we're going to discuss about another important lecture that is going to be on parabola, right? So, as of the last lecture, we have been so far discussing with the concepts regarding the tangents to a given parabola, right? And we have seen that how to write down the equation of a tangent to any given parabola, right? So, in that particular respect, we learnt about how to write out the equation of tangent in form of the parametric form or in the slope form or in the slope form, parametric form and the differential approach, right? So these are the all the three different approaches we have learned so far in our ongoing discussion, right? And along with that, in our last discussion we have been discussing with the equation of a normal to a given parabola at a given point, right? So these are the all contents we have been discussing in our upcoming lectures, right? And also we'll be trying to discuss about some more concepts regarding the normals, and so we'll discuss about the properties of equation of a normal to a given parabola, right? So these were all so far we have discussed in our particular discussion of parabola, right? So welcome back to this lecture number 6 of parabola, and today we're going to discuss about some of the miscellaneous questions on normals, and along with that we're going to solve some of the properties and understand how we will be using those properties to solve problems, especially in the JEE mains examination. Okay, so with this all things, let's get started with today's lecture. And if you're into this particular platform, I would request you to subscribe to the channel and also hit the like button so that whenever we are live you get a direct notification. Okay, so with all this particular thing, let's get started. All right, so if I recall quickly about the equation of normal to a given parabola, then we have seen that to a given parabola, if at any point I want to draw the equation of normal, so from the differential approach at a given point we get the slope of the tangent, and from there we can also get the slope of the normal, right, which is basically negative of y by 2a, right? So once we get the slope of the normal, then at a given point x1 y1 I can easily draw the equation of normal, that is going to be y minus y1 is equals to minus of y1 upon 2a times x minus x1, right? And in a similar approach we know that the point x1 y1 can also be given in terms of parameter, that is given as at square comma 280, right? And this is also called as a parametric form of a point for a given parabola, right? And with that respect, if I substitute at square comma 280 in this equation of the normal, then I'm going to get this particular form as the equation of the normal to a given parabola, right? Now over here, if you substitute over here, you will see that negative t is equals to m, which is the slope of the normal, right? So therefore in the slope format we can also write the equation of normal as mentioned over here, right? So this is all the things that we have discussed so far in our last class, right? And along with that I have also discussed about that how to obtain the equation of normal in case if it is not a standard parabola, right? So just simple transformation from the x and the y axis will actually help you to perform this sort of operations, right? And along with that we have been like I gave you these 7 questions as a homework problem. Okay, so please do let me know how many of you have done these problems. Okay, so do let me know in the live chat, are you able to do these problems or not? Okay, if you're able to solve this problem, do let me know the answers, or else we can discuss about if you have any doubts. Okay, so with all these things, let's get soon into our main discussion of our topics. Okay, so if you have any doubt, you can let me know in the live chat, or else we shall proceed with today's lecture. Okay, I hope this is clear to all of you. Is it clear? Okay, so let us quickly discuss about some of the problems to a given parabola. Okay, so let us discuss about some of the important problems especially. So let us try to solve the first problem over here, which is a prove that question. Okay, so in this question we have to prove that, so this is a question where we have to prove that the length of the intercept on the normal, the length of the intercept on the normal at a point P of a parabola y square is equal to 4ax made by the circle described on the line joining the focus and the point P is given as a square root of 1 plus d square, right? So let us try to understand what this question actually trying to say, right? So if I again draw the parabola over here by drawing the coordinate axis, So this is the x and the y axis, and then this is my standard equation of the parabola, that is given as y square is equals to 4ax. Okay, this is the standard equation of the parabola. And if at any point p, that is 80 square comma 280, if at any point p, if I draw a normal to this particular parabola, so if I draw a normal to this particular parabola at this point p, then so the normal to the parabola at this point p, what we have to prove is that we have to prove that the length of the intercept on the normal at a point p of the parabola is made by the circle describing on the line joining the focus and the point P. Okay, so if I take the focus of this parabola and I try to draw a circle with the PS line as the diameter, something like this. Okay, something like this. Then let me draw it properly, because since this is a normal, it should pass, right? At least it will look something like this. Okay, where this particular distance is this point is n, and this should be perpendicular, right? Because any point on the arc of the circle makes an angle, or is at an angle of 90 degree with respect to the diameter of the circle, right? So from this particular setup of the question, what we have to find out is that we have to find out that the length of the intercept made by the circle describing on the line joining the focus and the point P as diameter is just this particular distance, right? So before we start to discuss about that, let us first of all write down the equation of the normal. Okay, equation of the normal to this parabola at point P. Okay, so let us try to write down the equation of the normal to the point parabola at point P, which is given as 80 square comma 280, right? The point P is given as 80 square comma 280, right? So if I try to write down the equation of the normal, we have seen that the normal equation of the parabola in terms of parameter t can be given as y equals to minus tx plus 280 plus 80 cube, right? This is the normal equation of a given parabola in terms of parameter t, right? Now since this, or let us assume, or let us see that over here that the parabola intersects the circle at point n, right? And we know that from circle properties that s n p, this particular angle should be equals to pi by 2, right? Because any point on the arc of the circle always, or the major arc of the circle always subtend an angle of 90 degree at the diameter, right? So therefore this is also the concept of angle in a semicircle, right? So from this we can apply the Pythagoras theorem, and we can say that Pn square will be equal to Sp square minus of Sn square, right? Now since Sn is perpendicular to the normal, so from here, since Sn is perpendicular to normal, therefore, and also SP distance can be easily found out, because this is the distance of a point from the focus, which is similar to that of the distance of that particular point, or perpendicular distance of the point from the directrix, right? And that is going to be equals to a plus at square, right? And in a similar manner we can approach the Sn distance, because it is a perpendicular distance from the focus to the normal. We can get this distance as 80 minus of 280 minus of 80 cube and mod of it divided by square root of 1 plus t square, divided by square root of 1 plus t square, and this will turn out to be 80 times square root of 1 plus t square, 80 times square root of 1 plus t square, right? This is the value for Sn, right? Now from these two values of Sn and Sp, we can easily calculate the distance of Pn by doing this Pythagoras theorem over here. So if I simplify this part out, so what we're going to get is over here is that, so I can take 1 plus t square as common. So these are few lines of algebra which I think everyone can do it, right? And also I can take a square as also common, right? So in this case I will be left out with 1 minus a square. Okay, 1 minus, just let me check, am I correct? Oh, there is a square term we have missed over here, right? So it should come out as 1 plus t square minus t square. Okay, so this t square get cancelled, and ultimately we are left out with the Pn square distance as a square multiplied with 1 plus t square, right? So therefore from here the Pn distance will be a times square root of 1 plus t square, right? So this is going to be a final answer. Okay, so therefore I have easily proved that the distance of the length of the intercept, the length of the intercept on the normal at a point P to the parabola is made by the circle describing the line joining the focus and the point P as a diameter is given as a square root times of 1 plus t square. Okay, so we have been able to prove that whatever is given in the problem. Is this part clear to all of you? Is this question clear? Is this part clear to all of you? Do let me know in the live chat. Okay, so this is a very interesting simple problem. Okay, now let us quickly go on to discuss about the properties of normals, right? So let us discuss about the properties of normal. Okay, so let us discuss about the properties of normal to the parabola. Okay, let us discuss about the properties of normal to the parabola, right? So the very first property of the normal to the parabola is that normal other than the axis of the parabola never passes through the focus. Okay, so what I'm trying to say is that if I draw normal to a given parabola, so if I draw a normal to the parabola, let us say at any parabola, normal other than the axis of the parabola, so if I draw a normal, then it will never pass to the focus. Okay, so if I only draw this particular thing as a, so if axis is my normal, other than axis, no normal will pass through the focus of the parabola. Okay, so if at any point, if I draw the normal, this normal will never pass through the axis or never pass through the focus. Okay, so normal except the axis never pass through the focus. Okay, so this is a very basic thing that we need to also take in mind. Okay, and it can be easily proved that because if at any point P, let us call the point in term of the slope, so that is basically am square minus 2am, because minus of t is the slope of the normal, right? So in this case, if I try to write down the equation of normal, that is y is equals to mx minus 2am minus am cube. Okay, then if I say that this particular point passes through the focus, that is basically a comma 0, then in order to satisfy this equation must be holding true, right? Oh, sorry, uh, this will be m, right? So m minus am cube, right? So this equation must hold true, right? So if I simplify this equation further, what I will get it is that I'll get an equation like m squared plus 1 times a of m is equals to 0. So since a cannot be 0 and also slope of the normal cannot be 0, therefore m square plus 1 is always positive and it cannot also be 0, right? So this particular equation will never hold true, right? So this particular equation will never hold true for real m, right? So no solution, right? So therefore there is no such roots of a normal which will pass through the focus, right? So therefore no normal can pass through focus. Okay, is this part clear? Is this part clear to all of you? Please do let me know in the live chat, is this part clear or not? Okay, so therefore the normal except at the axis of the parabola will never pass through the focus. Okay, so this is a very important understanding that we need to keep in mind, that whenever we are drawing a geometrical conditions of a for normal to a given parabola, then these particular things must be holding true. Okay, is this part clear? Okay, so let us now deep dive into the next important property, that is the point of intersection of normal. If I draw normals at 2 points, okay, so for a standard parabola, let us take a standard parabola. So if I draw normal to the parabolas at 2 point P and Q, which is given as a t2 square comma 2a t2, if I draw the normal to this point P and the normal to this point Q, the normal to this parabola at point Q, okay, please note that this is a normal and let us say they intersect at point N, right? So this point of intersection of the normal is basically given as, now this is again very interesting, because in case of point of intersection of tangents, we have seen that it is basically the GM of the 2 points of the x-axis and the AM of the 2 points of the y-axis, which is representing the y coordinate, right? So therefore in this case the point of intersection of the normal is given as 2a plus a times of t1 square plus t2 square plus t1 t2, right, comma minus of a t1 t2 times T1 plus T2. Okay, now this bit different result. It is also quite heavy. So I don't suggest you remembering this result. However, you can easily derive that by writing down the equation of normal at this 2 point P and Q, and therefore you can find out for the point of intersection. Okay, so there is no point in remembering this big expression. Okay, so you can go with the basic formula, right? Writing down the equation of the normal to the 2 points, and then you try to solve that two equation. Okay, so I won't suggest you remembering this, right? So the third property of the normal, okay, that is said that if I try to draw normal to a parabola at a point which is given by the parameter t1, so if I try to draw a normal to the parabola at point t1, at point whose parameter is given as t1, it will touch. So if I draw the normal at point p, it will touch the parabola at point q whose parameter is given as t2, and then I can write t2 as minus of t1 minus of 2 upon t1, right? So this is how I can write down the point where the normal intersects the parabola or the curve again, and that particular parameter can also be given in terms of so T2 can be given in terms of T1, right? Now this is a very interesting result which I can try to show you that how we can approach this particular result. Okay, so it's very simple, right? Let us try to draw the equation of the normal at point P. So equation of normal at P, which is given by the parameter T1. So equation of the normal at point P, which is given by a T1 square comma 2a T1, right? So if I try to draw the equation of normal, it is basically y is equals to minus of tx plus 2at plus at cube, right? And therefore if I try to see the solution, so since it is drawn at T1, right? So if I try to see the intersection with the curve, that is y is equals to y square is equal to 4ax, and if I substitute over here, okay, so what I can do over is that now since it intersects the curve again at point q and whose coordinate is given as a t2 square comma 2a t2, so therefore if I substitute over here, it will also satisfy this equation, and therefore I will get 2a t2 will be equals to minus of minus of t1 times of a t2 square plus 2a t1 plus a t1 cube, right? Now if you simplify this expression, so if you try to simplify this expression, so 2a times of t2 minus t1 plus a t1 times t2 square minus t1 square, and that is equals to 0. So from here I can simplify, I can take t2 minus t1 as common with a also as common, then I will get 2 plus t1 times of t2 plus t1, right? And since t1 and t2 are different, so therefore this cannot be equal to 0. So the only thing that is remaining is that 2 plus t1 times of t2 plus t1, this should be t1, this should be only equals to 0, and this can be true when your t2 is equals to minus of t1 minus of 2 upon t1, right? So this is going to be the final result. Okay, so this is how you can easily obtain the result for the point where the normal ways again intersect the curve. Okay, so this t2 can be given in terms of t1. Is this part clear to all of you? Is this part clear? Do let me know in the live chat, is this part clear or not? Okay, is the solution clear to all of you? Quite basic results, I believe. Okay, but this is a very interesting result that you can keep in mind, and we can be trying to use this result as far as possible in solving questions. Okay, so we'll try to solve questions with this particular results. Okay, all right, is this clear? Right, so let us now try to solve some problems, and let's try to check some problems that what kinds of problems are generally being asked in your JEE Mains examination. Okay, so this is a very interesting problem, and it's a very repetitive problem you can see in your JEE Mains problem, that is the question of locus with the normal to the parabolas, right? So this question, we have to find out the equation of that particular locus for the point of intersection of two parabolas. Okay, so you have to find out the locus equation of the point of intersection of two normals to the parabola which are at right angle to each other. Okay, so what you have to find out is that you have to find out the point of intersection of two normals which is right angle to each other, right? What does this mean? That if I say, let us take a standard parabola. So if I take the standard parabola as an case, so that is y square is equal to 4ax, And if I try to write down the equation of the normal at any point P, okay, let us say x1 comma y1, or then that can be given in terms of slope form, that is mx minus 2am minus of am cube, right? This is the equation of the normal to at any given point P, right? Now from this, if we say that this particular point, and I want to find out the locus of the point of intersection of two normals, which is basically intersecting at a right angle, okay? So this point P and this point Q, and let us say this is given in terms of the slope over here is given in terms of m1, the slope over here it is given in terms of m2, right? Now I have to find out that the locus of the point of intersection, let us say that is given as, the locus is given as h comma k, right? So if this particular normal passes through the point h comma k, then it will be satisfying this particular equation of the normal, right? So if I satisfy this equation of normal over here, I will get k is equals to mh minus 2m minus am cube, right? And from here I will get am cube plus m times of 2a minus of h plus of k equals to 0, right? Now if I say that since this is a cubic equation, what I can understand is that for a normal passing through a point h comma k, there can be three possible solution of normals, right? So from here, since this is cubic equation, so the roots of this cubic equation can be m1, m2 and m3, okay? So the roots of the cubic equation can be m1, m2 and m3, right? Now since it is said that we will need to find out the perpendicular normals, okay, so since we need to find out the perpendicular normals, okay, since we need to find out the perpendicular normals, so therefore two of the normals will have the product as minus of 2, right? So since this is basically trying to mean that if you take up any point h comma k, and from there if you want to draw a normal, then there is three possible normals, right? Out of them, these two normals, let us say this m1 and this m2, these two normals are perpendicular to each other. That means they are having the product of the slope is equals to minus of 1, right? So therefore if the m1 m2 is equal to minus of 1, and from our theory of equation, what I can write is that m1 m2 and m3 should be equals to minus of k upon a, right? And m1 m2 is equal to minus of 1, so from here I'll get m3 is equals to k upon a, right? So from here I can easily get the value of m3, that will come out to be k upon a, right? Now since m3 is also the root of this equation, so if I satisfy this equation, it will definitely be equals to 0, right? So therefore a times of k by a whole cube plus m times of, so m is basically k by a, so 2a minus of h plus of k is equal to 0, and therefore simplify this equation in terms of k, so I will get k square plus a times of 2a minus of h plus of a square is equals to 0, and so from here I will get k square is equals to a times of h minus 3a, okay? So therefore this is going to be the result for k square, right? And what we need is that we need an equation in h comma k, and this is the required equation in h comma k, which is devoid of any other unknowns, right? So therefore the locus equation from here can be given as y square is equals to a times of, because a is a constant, x minus 3 times of a, okay? So this is again a parabola. So the locus of the point of intersection of two normal which is at a right angle to each other, then that is also a normal, or that is also a parabola, okay? So this is the locus of that particular question. Is this part clear to all of you? Is this solution clear to all of you? Okay, so this is how we solve or try to see how we can solve this question of locus, okay? Because these kinds of problems are very useful, especially for your JEE Mains examination. Therefore this questions is very important, okay? So please take a note of this problem, because there are multiple steps involved in order to solve this problem, okay? Okay, so please take a note of this problem. This is a very interesting problem, and we need to be careful enough whenever we are solving these kinds of problems, okay? Is this part clear? Is this part clear to all of you? Okay. So if this question is clear, let us now discuss about another important concept, that is the concept of conormals, okay? So let us discuss about the concept of conormal points. Okay, so let us discuss about the concept of conormal points, okay? So what is a conormal point is that, so at any given point, so at any given point, which is basically given as h comma k to the parabola, so at any given point from h comma k to the parabola, that is given as y square is equals to 4ax. So y square is equals to 4ax. So from any point to the parabola, if I try to draw a normal of the slope m, then the equation of normal can be given as y equals to mx minus 2am minus am cube, right? And if it is positive h comma k, then this equation is satisfying. That is basically k is equals to mh minus 2am minus of am cube, right? This is going to be satisfied, right? Now, what I can observe over here is that what I can easily see that from any given point to the parabola, what I'm trying to also see in the last question as well, right? So if I try to draw any, take up any point h comma k, which is outside or inside, I don't care. But if I try to draw normal to this parabola, then I can see that there are three sets of line which is going to represent the normal to this parabola. Okay, so three sets of line is going to be representing the normal to this parabola. Okay, so there are three sets of normals that I can draw from a point h comma k to a given parabola. Okay, so this point, since this is a cubic equation, that means there will be three solution of m's. So therefore, for a given point h comma k, which is p, has maximum three real root, and corresponding to this each of this real root, we will have one slope which is passing through this point h comma k, right? And there, hence in total we have maximum three normals that can be drawn from a point p, and these points a, b and c. So therefore, if I try to write down the point where this intersect the curve a, b and c, these points a, b and c are therefore called as a are the three normals points, and these points are also known as the conormal points. Okay, so the conormal points are nothing but the point of intersection of three normals to a given parabola. Is this part clear? Is this part clear to all of you? Okay, now there are certain properties of these conormal points what we will try to also discuss, right? So the very useful property from here is that if I say that if we try to represent the ordinates of these 3 points, so if I try to represent the ordinates or the points of these points a, b, c in terms of slope, what I can write a as a m1 square comma 2a m1, right? This is how we can write it down, sorry, minus of that, right? In the similar manner, I can write b point as a m2 square comma minus of 2a m2, right? Similarly, a c point as a m3 square minus 2a m3, right? So these are the 3 points, right? Now from here, if I look into this expression over here, if my roots are m1, m2 and m3, if m1, m2 and m3 are the roots, therefore the summation of the roots, the summation of the root is always equals to 0, right? Because there is no m squared term, right? So from here, if I sum up the y coordinates of these points, so if I try to sum up the y coordinates, so y of a plus y of b plus y of c, this will turn out to be 0. Okay, so this is a very interesting property regarding conormal points, right? So the algebraic sum of the ordinates of the three normals drawn to a parabola at a given point is always equals to 0. Okay, or the y coordinate ordinates of the conormal point is always equals to 0. Okay, so this is a very interesting result, and that also means that if I try to draw a triangle with these three conormal points and the y coordinate of the centroid, and if I try to draw the centroid or write down the centroid, okay, the y coordinate of the centroid, so let us call it as g. So the y coordinate of the centroid is always equals to 0. Okay, so if I try to draw the centroid, the y coordinate of the centroid will be 0. Is this part clear? Is this part clear to all of you? Okay, so this is a very important and crucial result that we will try to use it up while solving problems. Okay, Naman Raj is asking, are you in college? Yes. Is this clear to all of you? Is this part clear? So we will also see some problems and we'll try to solve them up in our next class. Okay, so one of the very interesting problem that I feel that it is very important, especially for your upcoming JEE mains paper, is this kinds of problems. Okay, so all right, so there is some issue you can see. All right, okay, so these kinds of problems are very useful for your JEE mains paper. Okay, so what I would like all of you to do is that please try to solve this problem. Okay, so it is said that if the three distinct normals can be drawn to a given parabola like this from a point 2a comma b, then find the range of the values of a. Okay, so to find out that particular range of a for which the three distinct normals can be drawn to this parabola. Okay, this is a question of theory of equation more than a question of normals, right? Because when you draw a normal from a exterior point, the three normals can be drawn. That basically means it's a cubic equation for the equation of normals or the slope of the normals, right? Now, if that cubic equation will have three distinct roots, that means three real roots, then you have to apply the concepts of your theory of normals. Okay, so please try to solve this problem by using that concept of theory of normals, and you can easily do this problem. Okay, so just give your try, and if you're unable to solve, we can definitely discuss on these kinds of problems. Okay, so I hope today's class is clear to all of you. So in today's class, we learnt about another important properties of the normals, and along with that, we also discussed about the co-normal points, right? Which are a very important and crucial concepts, especially for your JEE mains paper. Okay, and along with that, we also saw that how to solve problems of locus for a given normals of a parabola, right? So those were the important parts of today's lecture, and with this part, we are almost done with the normals and the tangents part, and then it's our time to discuss about some of the miscellaneous properties regarding the parabola, right? Now, another very important application of parabola is that we use parabola as a reflector. Okay, so in order to have a perfect reflector, we will use parabolas, right? For example, if you want to reflect lights coming from infinity, so if you want to reflect light coming from infinity at the focus, then that can be only done if I use a perfectly parabolic mirror. Okay, so all the lines from the infinity will be passing through the focus. Okay, this is a very important property, right? And also after a line from the focus, after getting reflected, it will again pass through pass to the infinity. Okay, that is a very important result. Okay, so this is a very important result which will allow us to use it as a parabolic mirror. Okay, so parabolic mirror is one of the crucial application of parabolas. Okay, so we'll see that what is the basic feature of a parabola that makes it a perfect reflector. Okay, so that is all what we will discuss in our next classes or upcoming lectures, and along with that we're going to discuss about the miscellaneous topics like the chord of a given contact or chord with a given midpoint. Okay, and with that we are almost done with the chapter, and then we can proceed with solving some previous year questions, and then we'll be starting with our new chapter, that is ellipse. So you can assume that by 2 more lectures we can be wrapping up with our portion of parabola, right? So then we start with ellipse, and also after finishing off ellipse we will start with hyperbolas. Okay, so therefore you can assume that in the something like 6 lectures for ellipse and some 6 lectures for hyperbola can be taken up. So therefore in 12 more lectures we will be easily covering or completing the entire portion of coordinate geometry. All right, so I hope this particular part is clear to all of you, and with this part we try to conclude our session over here, and I hope you have enjoyed solving these problems and also understanding the properties of normal, right? So with this part I hope to see you again in our next class. Naman Raj is saying, I found 3D difficult for me. Okay, Naman Raj, I think you have studied it from the wrong teacher. Okay, but I feel like if you go through my lectures, okay, if you have studied it from this particular platform itself, then I think the concepts of 3D must be very easy, right? Because the way I have discussed 3D geometry, I think people will have no questions after that, right? So please watch those lectures, okay? The 3D is a very interesting concept, very easy, and it is highly scoring. Okay, so therefore learning about the 3D geometry is very important. Okay, so try it up again or watch those particular lectures again, and I think after that you will be easily able to do those questions. Okay, and don't always focus on the question, try to get the basic understanding of the 3D, and then you try to solve the problems. Okay, planes is difficult for you, plane is very simple, right? Try to understand the basic of how to write down the equation of planes, and also learn about the cross product. Okay, because for writing down the equation of plane we need two things. One is the point on the plane, and another is the normal that is representing the plane, right? So the two things can be easily obtained from the simple vector results, right? So the point is already given to us, or if we don't know the point we can also do it by some other means, and in order to find the normal we need to have an idea of two vectors which is lying on the planes, right? And by taking the cross product of the two vectors lying on the plane, we can easily formulate the normal to the plane, and then we can write down the equation of the normal, right? So all those types of questions and all the different modification that you can see in the problems, I have already discussed in our vectors and 3D geometry lectures. Okay, so please watch those lectures and then you ask the same question again. Okay, so with this part, I wish you all the best and I hope to see you soon in our next live class. Thank you and bye bye.